In this video, we're going to evaluate finite geometric series. Let's say we have the following geometric sequence. I know that my first term is of course 2, and my common difference is, well, 12 divided by 2, this number divided by this number, that's 6. So that's important for me to know that. Now I'm going to find a series. Now series, remember, represents the addition. So I have 4 numbers that I'm going to add. I will use the following formula. The sum of the following 4 numbers is going to be a1 times 1 minus r to n power divided by 1 minus r. This is for any value of n. It can also be rewritten as s of n is a, the first term, times 1 minus r to n power, the whole thing divided by 1 minus r. These two equations are equivalent, they are the same. So now let's go ahead and find s of n. The sum of the following 4 terms is going to be a1, which is 2, times 1 minus r, that's 6, to the 4th power divided by 1 minus 6, 518. And that's it. Let's try another one. Let's say we want to find the sum of these geometric series. Of course, I can put things in a parenthesis for you to see how the terms separate. Again, I know the sum of 1, 2, 3, 4, 5 with the following 5 terms is going to be the first term a1, so that's -2 times 1 minus the common ratio. In this case, the common ratio is what? Let's see. From 6 to the -2, it looks like it's -3. So I have -3 to the 5th power divided by 1 minus -3. So let's see, we can say it's -2. So this is equal to -2 times 1. So this will end up being plus 3 to the 5th power, because this is an odd number. So when I apply the power, there is still going to be a negative left. And this negative with this negative will become positive over 1 plus 3. So again, I have -2, 1 plus 3 to the 5th power over 4. So I can see that this will cancel with this. So I end up with -1 plus 3 to the 5th power over 2. I will get -122. Another example here. So suppose I have the summation of 4k to the -1, k starting from 1 and ending at 7. So the first thing I need to realize is this has a form of a geometric sequence because it's exponential. Okay, all right, so let's find the first term. To find a1, I will substitute this one here. I will get 4 to the 0 power, which is 1. So a1 is 1. And what is r? The common ratio is of course this number right here, that's 4. We know that the formula says, so let's see what we have here. The sum of the 7 first terms of this geometric sequence is going to be a1, which is 1, times 1 minus the common ratio, which is 4 to the n power, which is 7, over 1 minus r, which is again 4. And that will give us 5,461. And that is our answer. One last example. Suppose I have now, so let's write the formula again. Then let's see, what is a1, the first term. So how do I know the first term? Let's see. Now remember, a1 times r to n minus 1. So if we compare this form with this form, we'll see that a1 is equal to 2. So a1 is equal to 2. And how about the common ratio? The common ratio is of course -2. The partial sum of the first 8 terms, again I get 8 from here, it's going to be equal to a1, that's 2 times 1 minus -2 to the 8th power over 1 minus r, -2. So here, because this number is even, it's going to cancel this negative. So you will end up with 2 on the outside times 1 minus 2 to the 8th power over, that would be 3 on the bottom. Okay, and your answer is going to be -170, and that is your final answer.